Hey guys, so what I wanted to do for week 2 is review a few things before we move on to something new during week number 3. So the first thing I wanted to look at was something that we looked at before we left for spring break and this extended break, and that's factoring. So remember when we factor trinomials, or anything really, we talked about using the area model. So the first thing that I would do, so I'm going to factor 2x squared plus 11x plus 15. The first thing I would do is draw my area model. So we want to have those 4 boxes. And remember in my area model, what goes in the top left box is the first term, the x squared term. So in this case is 2x squared. Sorry, my writing's a little off there. And then in the last box, the bottom right box will be our constant term. In this case is 15. And then we talked about how we can figure out what goes in those other 2 boxes. Well, we know that when we multiply those 2 things together, 2x squared and 15, we get 30x squared. And whatever we multiply in those 2 boxes has to be the same when we multiply the other 2 boxes. And those 2 things actually have to add up to that middle term, which is 11x. So we're trying to add to get 11x and multiply to get 30x squared. So the 2 things that will do that would be 5x and 6x. And that's what we want to fill in the other 2 boxes. It does not matter which one you put where. I could have put the 6x up here and the 5x down here. It doesn't matter. So then from here, we're going to try and create our 2 binomials or our 2 factors. So we're going to look at this top row, and we want to find the greatest common factor. So if we look at the 2 and the 5, 1 is the only thing that those have in common, but they both have an x. So that's what we want to take out of that first row. And then we can build off of that x. So what times x is going to give us 2x squared? That would be 2x. What times x would give us 5x? That would be 5. And then 2x times 3 would give us 6x, and that last piece is correct. 5 times 3 does give us 15. So from there, we can just write our 2 binomials. So our first one would be 2x. Sorry about that. I don't know. I was writing 2x plus 5. And then the other binomial would be x plus 3. All right, so let's look at another problem. The second problem says factor the following 3x squared plus 4x minus 4. So same concept. We still want to use the area model for this one. So we want to draw our box. And that first term, the x squared term, is going to go in the top left part of our box. And then the minus 4, be careful here. Remember, you always want to take out that sign that's in front of the constant. And if we multiply those 2 things together, 3x squared and negative 4, that'd be negative 12x squared. And then that middle term is our 4x. So we want to add the 4x and multiply to negative 12x squared. So if we're multiplying to get a negative, that means that one of these values has got to be negative. And what values multiply to get 12? Well, 2 and 6, 3 and 4, 1 and 12. But if we make this a negative 2x, and this a positive 6x, those do in fact add up to get that 4x and multiply to get that negative 12x squared. So again, we want to fill in those missing 2 values, negative or 6x and negative 2x. And we want to start at that top row. So the greatest common factor of that top row would be 3, and they also have an x. What times 3x would give us 3x squared? That would just be x. What times 3x would give us 6x? That would be 2. And x times negative 2 would give us negative 2x. And that last piece, 2 times negative 2, would be negative 4. So our binomials are x plus 2. I'm getting that from that top part. And then 3x minus 2, which is written down the side. All right, let's look at another problem. Okay, the next problem I want to look at is this one. It says 4x squared minus 21x plus 20. So again, we want to go ahead and make that area model. So 4x squared goes in the top left box, 20 goes in the bottom right box. We multiply those together, we get 80x squared. And the middle term is negative 21x. So if we think about this, we want to multiply to get a positive, add to get a negative. So that first indicator tells me that both of those values are going to be negative. And then we want to think about the factors of 80. 80 and 1, those aren't going to add to get 21. 20 and 4, or sorry, 20 and 4, 40 and 2, none of those are going to add together to get negative 21. This one might not be as obvious, but it is negative 5x and negative 16x. And that's what we want to fill in those other two values here. So if we look at that top row, the greatest common factor would be 4x. 4x times x would give us 4x squared. 4x times negative 4 would give us negative 16x. And x times negative 5 would give us negative 5x. And negative 5 times negative 4 would give us that 20. All right, the next one I want to look at is a little bit different. So for this one, the other three problems we've seen have been expressions. This one does have an equal sign. So before we factor it, we actually need to have it equal to 0. We can't have it equal to anything other than that. So the first thing I want to do is move over this 13x to the left-hand side. And I'm going to write this in standard form. So our squared term comes first. And then negative 13 or x term is going to come next, plus that 36. And now that these 13x's are gone, it does equal 0. So no different. We still want to set up our boxes. So x squared and 36. And when we multiply those together, we get 36x squared, obviously. And then that middle term is negative 13x. So again, same thing as the previous one. Both of those are going to end up being negative. So what values multiply to get 36? Well, that would be 36 and 1, 18 and 2, 3 and 12. But actually, 4x and 9x are the two that are going to give us that 13. So I'm going to fill those in here. And the greatest common factor of that first row is x. X times x would give us x squared. X times negative 4 would be negative 4x. And x times negative 9 would give us negative 9x. And if we want to double check, negative 9 times negative 4 does give us 36. So we do have, hold on one second, sorry about that. We do have x minus 9 times x minus 4. But before we just had expressions, and that was as far as we could go. But now these two things are equal to 0. So remember we talked about now that we want to set each of those equal to 0, x minus 9 is equal to 0, and x minus 4 is equal to 0. And if we solve each of those pieces, x is equal to two things. It's equal to 9, and it's equal to 4. And if we want to be really specific, we want to write this as a solution set. Oops, excuse me, not negative 4, positive 4. So we list the smaller values first and then the larger value. Okay, and then the last problem I want to look at is similar to the first one, but this one we need to do something first. So this on the other problem. Anytime you have a quadratic, the first thing we want to do is see if there's a greatest common factor, meaning, is there a number I could divide all of those terms by? Well, there is in this case. In this case, it's 3. So we can actually factor out a 3 first. And then 72 divided by 3 would be 24. And it's not wrong to not do that, but it's definitely going to make our factoring a lot easier because we're going to have smaller numbers we're working with in our box method. So for now, we're going to ignore that 3. So we have the x squared and 24. Remember, I'm working from this new one. So 24x squared and then negative 11x. Again, we're needing two negatives here because we're adding to a negative, multiplying to a positive. So the factors of 24, 6 and 4, 12 and 2. This one is 8x and 3x because those add up to get negative 11x. So we have an x is the greatest common factor of that first row. X times x gives us x squared. X times negative 8 gives us that negative 8x. And x times negative 3 gives us negative 3x. And then those two things do multiply together to get 24. So we have x minus 3 and x minus 8 equals 0. But we cannot forget about that 3 that's out in front. It is important as far as naming the factors. And then we can finish out this problem. We want to set each of those equal to 0. So 3 times x minus 3 equals 0. and then x minus 8 equals 0. So when we solve this first one, we want to divide by 3 on both sides to get x minus 3 equals 0. So x is equal to 3. And over here, x is equal to 8. And again, you want to write these as a solution set. So that would be positive 3 and positive 8 as our two solutions. These are the two specific solutions that make this quadratic equal to 0. All right. Again, if you have any questions, make sure I'm also attaching the written part of these notes to my website. So look at those if you want to look over some examples. And remember, text me on reminder email if you have any questions. Bye, guys.